Hi guys, Geekonomics here, and today I'm going to run through the short run cost curves of a firm, the derivation of them, because it's particularly important for those of you who are studying for the A2 F583 paper or the A2 F584 transport paper. So I'm going to start with a little recap on the law of diminishing returns, because really all of these short-run cost curves require an understanding of this thing called the law of diminishing returns. So you'll know that the law of diminishing returns is a theory which deals with the short run, i.e. the period of time in which there's at least one fixed factor of production. Any textbook that you look at will probably use the example of agriculture, where you have the fixed factor being the land and the variable factor being the labour. And the whole purpose of the law of diminishing returns is to find the most efficient combination of the fixed factor, the land, and the variable factor, the labour. So it's the land and the labour that we're combining. Very important, when you're talking about the law of diminishing returns and you're outlining whether or not there are increasing returns or decreasing returns, remember it's increasing returns to a factor, the factor being labour in this case. It is not increasing returns to scale, because of course scale would be a long run scenario, whereas the law of diminishing returns is primarily a short run theory. So I'm not going to get into the whole numbers game with regard to the derivation of the total product curve. I've just drawn it here. I'm sure you've done this before and you can consult your textbooks for this, but you'll know that this is the general shape of the total product curve. And you'll see that I've drawn directly beneath it an additional two sets of axes. Very important that you do this. So you can see in the first instance here we have the total product curve increasing at quite a rapid rate, and it rises fairly rapidly up to about this point here on my diagram. Now that is an indication that the total product obviously is rising quite rapidly. Why will it be rising quite rapidly? It will be rising rapidly because the combination of the fixed factor and the variable factor will be getting more efficient. So that means, for example, worker 1 adds 10 units of output, worker 2 adds 12 units of output, worker 3 adds 15 units of output. So the total product is increasing at an increasing rate in that respect. And another way of saying that, of course, is that the marginal product, remember your definition of marginal product, the change in total product from employing one additional unit of labour, the marginal product will be increasing. And this is why it's important, ladies and gentlemen, to draw your two sets of axes beneath this total product curve. So what I'm going to do is, at this point, I'm going to take a dashed line down and just put it right through these other two axes. So first thing to note is that from 0 up to this point here, we have increasing returns, and that's increasing returns to a factor in this instance, increasing returns to a factor. And I've just explained to you that that will mean that marginal product will be rising. And so on the diagram beneath, where we've got marginal product on the y-axis, I'm going to draw, and you can start at this point, and you can start this anywhere really, but the key thing is that it's rising up to that point. Where we've got increasing returns to the factor, we've got the marginal product rising. Now you can see on this last set of axes I've got costs. If the marginal product is rising and if the total product is increasing at an increasing rate, that means that the combination of the fixed factor and the variable factor is becoming more efficient. And as it becomes more efficient, obviously, the costs every time that you employ an additional unit of labour, those marginal costs, change in total cost from employing an additional unit of labour, the marginal costs will be falling. And so on this bottom diagram, I'm going to draw marginal costs. So as marginal product is rising, we know that the marginal costs will be falling. So there's this sort of mirror image relationship going on here. Okay, so that's us started on that. We can then say that from this point onwards, we have diminishing returns to a factor. Diminishing returns to a factor. How do I know that? I know that because the curve is now starting to level off, which means that as I employ more units of labour, the additions to output, whilst they are increasing, they're starting to increase at a decreasing rate. And indeed, ladies and gentlemen, let's not forget that the definition of the law of diminishing returns, one definition is total product increasing at a decreasing rate. So it's still going up, but the marginal product is slowly getting smaller, smaller, smaller. Now at a certain point, it will be equal to zero. The marginal product will be equal to zero. Where will that be? It will be right here. And that means that, for example, total product when you employ 10 workers is 80. You employ the 11th worker, total product is still 80. So the marginal product at that point is zero. And so this is another key point to indicate between these two rather than down into your costs. So we know that we've diminishing returns from this point onwards. So that means that the marginal product, while still positive, it is starting to fall. But the key thing is that at this point here, it's equal to zero. And so we can draw this falling to this point here where it's equal to zero. And in fact, ladies and gentlemen, if you really wanted to be technical about this, we could say that this point here, this is where we have zero returns to a factor. And beyond this point here, where we have zero returns, we can see total product is falling. So 10th worker, total product is 100. 11th worker employed, total product falls to 95. And so that would obviously be negative returns to a factor. So if you've got negative returns, the marginal product is obviously a minus. And so the marginal product beyond this point goes into, it's below zero, into the negative territory. So that's our marginal product curve. I've already said that, if you flip this on its head, we would get it's a mirror image. And so as marginal product starts to fall, that means the efficiency of the combination of the fixed and variable factor becoming less efficient, more costly, and so the marginal cost curve therefore will be sloping upwards, like so. So you should, they are kind of a mirror image of one another. Now the important thing to say here, ladies and gentlemen, is we have just derived the first of our short run cost curves that we're really interested in, which is this one, the marginal cost curve. And you can see that it's U-shaped. And why is it U-shaped? It's U-shaped because of this thing called the law of diminishing returns. So this is something which I'll come back to in 3 or 4 minutes' time. So what I want to say is with regard now to costs. Here we have costs, here we have output. Here we have costs, here we have output. We can see here that we have the total fixed costs, and the total fixed costs are, as you can see here, they're perfectly elastic, they're constant, they're the same all the time. You'll know that your examples of total fixed costs are things like rent, interest on mortgages, interest on loans, that type of thing, council tax payments. So these are the things that even if you produce absolutely zip, you've still got to pay them. Variable costs start at the origin 0 and move obviously in this direction. So if you produce nothing, you need no raw materials. As you start to produce more, you need more raw materials, so variable costs rise. And then you'll know that the total costs, well, the total cost equation is total fixed costs plus total variable costs. And so consequently, if you start your total costs here, they will be rising like so, because you're adding, obviously, total fixed plus total variable. And the distance between those two curves, that distance there, that's your total variable, that's your total cost, and the distance must be your total fixed. Now, to be absolutely clear on this, if you were doing GCSE, this is the sort of model that you'd be looking at if you did break even at point analysis, that type of thing. However, you now know that the law of diminishing returns has an impact on efficiencies. And so actually, ladies and gentlemen, and those of you who go on to look at this maybe as you study economics at university, really, strictly speaking, the total variable cost curve and the total cost curve should have these, we refer to them as inflections. They should have these inflections in the curves. So this is indicative of increasing returns to a factor. So this scenario where we're getting more efficient. And then this scenario here where the inflection kicks up the other way is where we have the diminishing returns to a factor. So strictly speaking, your total cost curve should be like that. Now that's very important when it comes to the derivation of these short run cost curves, which I shall now talk about. Let me just move the camera along. Okay, so now let's talk about the derivation of these short run cost curves. So we've already derived one of them, which is the marginal cost curve, comme ça. You also know that obviously as the supply curve as well. Now, when it comes to drawing these cost curves, you know that total cost equals total fixed costs plus total variable costs. So if we're thinking about averages then, which is what we're talking about in the short run, we would say that average total cost is equal to average fixed costs plus average variable costs, like so. So therefore clearly the larger number here is obviously going to be the average total cost, hence the average total cost curve is going to be the top one. And the key thing to note about this is that the marginal cost curve always cuts these average curves, apart from the average fixed cost, but it cuts the average curves at their minimum point. So, like so, this being the minimum point on the ATC curve. Now this is, as again, a U-shaped curve, and why is it U-shaped? It's U-shaped because of the law of diminishing returns. Increasing returns to the factor, then diminishing returns to the factor. Let's then talk about the average variable cost. It's the next one. And it is also a U-shaped curve. It's also cut at its minimum point by the marginal cost curve, but one very important point is, and let me just draw it and then I'll tell you what it is. So this is the minimum point and then we go like this. You can see here that the distance between the average variable and the average total is getting smaller all the time. So that distance there is greater than that distance there, and I'll come back to explain why that is the case. But as I've already mentioned, if you draw this diagram out, that should be your minimum point on the average variable. And then finally we have average fixed. Now average fixed is obviously an interesting one because we've just looked at the total fixed cost curve where the total fixed costs are perfectly elastic, they're constant all the time. So average fixed costs equal total fixed costs divided by output. So let me give you an example. Let's say total fixed costs are equal to 100 and output is equal to 1. So therefore your average fixed will be equal to obviously 100. Let's take another example. So now you're producing more units of output. So output, let's say, is equal to 100. So now your average fixed are equal to £1. So clearly, as you produce more units of output, and because the total fixed are remaining constant all the time, the average is falling all the time. And so that is why the average fixed cost curve, ladies and gentlemen, falls continuously, like so. Now, the relationship, therefore, I hope is obvious between ATC, AVC and why they're converging like so, because you will know ATC equals AFC plus AVC. We know we've got AVC, we know we've got ATC, so we can scrap those out of this. So the distance between those two must be the AFC. And because the AFC falls continuously, this gap narrows continuously. So it's a very important point of detail, really, when you're drawing this diagram. So that's it, really, with regard to the derivation of these curves. The only sort of additional thing I would say on this is as follows. And again, you must kind of bear this in mind when you're thinking about your market structures diagrams that you draw. So let me just draw, for example, the long run perfectly competitive diagram. We've got price here and output. So perfect competition, average revenue equal to marginal revenue, average total cost curve, and the marginal cost curve. So that's sort of your standard typical diagram it's your average typical diagram for the long run perfectly competitive market. But the thing is, you've got to remember, implicit in all of these diagrams, we're only drawing the ATC curve, but we've just identified ATC, AVC, AFC and MC. We've just drawn those. So don't forget that when you're drawing these, actually lying beneath these all the time is, for example, the AVC curve, which is an important point actually of analysis when it comes to identifying whether or not firms can remain in business if they're only covering average variable costs rather than average total costs, for example. But do remember that these curves, these lie in behind and beneath the market structure diagrams that you're drawing all the time. Same goes for monopoly, monopolistic competition, etc. So it's a really interesting sort of topic this. I really find it fascinating, the whole notion of the short run cost curves of the firm, and I hope you do too. So that's it, ladies and gentlemen, that's the short run cost curves, and I'll be back another time. As ever, do message me any questions and I'll do my best to get back to you. Bye.